So the y coordinate of q is equal to 12 times 2 subtract 3 times 2 raised to the power of 2. So the y coordinate of q is 12. So the coordinates of q is 2, 12. We have to repeat something similar for p. The x coordinate is 5, so we have to substitute 5 in the place of x to find the y coordinate of p. So we have substitute the x coordinate of p into the function, which is 5. So we're going to find the y coordinate. The y coordinate will be equal to 12 times 5, subtract 3 times 5 raised to the power of 2. So the y coordinate of p is negative 15. So therefore, the coordinates of p is 5, negative 15. And that will answer part 1. It says state the range of g of x. So the range are the minimum and the maximum value of y. So the maximum value of y will be the y coordinate of q, which is 12, and the minimum value will be negative 15. So the range will be from negative 15 to 12. Y is between negative 15 and 12. That will be the range of the function. So the range of the function, y will be greater than or equal to negative 15, because that's the minimum value, and it will be the same y will be less than or equal to 12, which is the maximum value. The y range is from negative 15 to 12. From negative 15 to 12. Part 3 now is said, explain why g of x is a many-to-one function. So as we can clearly see, we have more than one x's going to the same y. So many x's going to the same y. Negative 1 is going to 15. And also 5 is going to negative 15. So negative 1 is going to negative 15. And 5 is going to negative 15. So many is going to 1. And that's a valid reason to state that the function is a many-to-one function. So in a nutshell, g of x is a many-to-one function because many x's map onto the same one y. Minus 1 maps onto negative 15, and 5 maps onto negative 15. Many maps onto 1. Now, part 4 says write down 2 suitable domain intervals so that g of x is a one-to-one. So this means that we're going to look at, well, half of the function. So there's a one-to-one from minus 1 to 2 is a one-to-one, and from 2 to 5 is a one-to-one. So x between negative 1 and 2 will give us a domain of a one-to-one, and from 2 to 5 we'll get another domain of a one-to-one function. So 2 domain intervals so that g of x is a one-to-one function are x between negative 1 and 2 and x between 2 and 5. So as you can clearly see, from negative 1 to 2, you have a one-to-one, that line, that curve that goes up there and it stops there. You not come back down yet, it just is right there. So that's a one-to-one. And from 2 to 5, x from 2 to 5 is another one-to-one function. So we have first form completed the coordinates of p by substituting -1 into the function to find the y coordinate. We get -15. We completed the coordinates of q by substituting the x coordinate 2 into the function to get the y coordinate 12. And we have completed the coordinates of p by substituting the x coordinate 5 into the function to get the y coordinate of -15. And the range is the y values stretching from the minimum value, which is -15, here it is, and the maximum value, which is 12, here it is. From -15 down here to 12, that's the range of the function. Then we moved on to state 2 domains. We have said why the function is a many to one, because many x's, more than one x is going to the same y, so many is going to 1, -5, 1, both -1 and 5 is going to -15, so many is going to 1. And two domain intervals to get a 1-to-1 is from -1, x from -1 to 2, and x from 2 to 5.